Hi, our question is choose the correct order of boiling point. Let us examine option A. Option A says that hydrogen is having less boiling point compared to helium. Is that true? Let us examine. So, to understand this question, we must know one concept: instantaneous dipole moment and induced dipole moment. So, what is instantaneous dipole moment? Take the example of hydrogen. So, this hydrogen molecule is formed by sharing two electrons between these two hydrogen atoms. So, due to some reasons, some fluctuations in the distribution of electrons in this molecule give rise to another structure which two electrons are present in one hydrogen and the other hydrogen is losing the electronic presence. So in that case, this will get a partial positive charge and this will get a partial negative charge. So this is the instantaneous dipole there. This will induce dipole to the nearby hydrogen molecule. Like this positive will attract the two electrons towards this side and this will become partial negative and this will become partial positive. So this dipole and this dipole interacts. So the hydrogen molecule, when we have taken, there is some kind of interaction like this. Similarly, in helium, there are two electrons. So if I write like this, it is neutral environment, like one electron is opposite to the another one. But due to some reason, this distribution gets changed to like this. Two electrons in the nearby position. So in that case, we can write a partial negative charge here, a partial positive charge here. So this will induce dipole to the nearby helium atom, and there also this kind of interaction will take place. So this will interact. While comparing these two, this linear shape hydrogen, this dipole will have more energy than compared to the spherical atoms in the helium. So in that case, we must apply more energy to break hydrogen-hydrogen molecule interaction in hydrogen and less energy in helium atoms. So we should write helium has less boiling point compared to hydrogen molecule. So option A is wrong. Coming to the second option, where we have BOH thrice and BOME3 thrice. So let us write the structure of BOH thrice. What is BOH thrice? Nothing but boric acid. So I am writing OH group as like this. So there we have three OH groups. So in this case, we can expect hydrogen bonding between the molecules. So how it will be? So the hydrogen atom of the nearest boric acid group and the oxygen of the other boric acid group will interact through hydrogen bonding, and we can expect three hydrogen bonding from a single molecule of this one. So coming to the other one, BOCH3, OCH3. In this case, we are not having any OH groups, so we cannot expect any hydrogen bonding in this case. So comparing these two, BOH thrice will have higher boiling point than BOMe3 thrice. Coming to the third option, C, NF3 less than NMe3. Me means CH3. I think all of you will be familiar of that. So first let us write the structure of these two. NF3 has a distorted tetrahedral structure. F, F, F and one lone pairs. Coming to this, N lone pairs, CH3, CH3, CH3. While comparing electronegativity of fluorine and nitrogen, fluorine is more electronegative. So fluorine will attract the electron cloud of the nitrogen towards fluorine atoms. So, and in the meantime, the lone pairs also attract towards the other direction. So the net dipole moment will be like this. So we expect more dipole moment here, but it is cancelled by the lone pairs of the nitrogen, and we are having a net moment equal to 0 or less. But in the case of NCH3 thrice, CH3 is an electron donating group. That means it supplies electron cloud to the nitrogen. That means nitrogen is more electronegative than CH3 or carbon atom, so it will pull the electron cloud of the CH3 group, and the net dipole moment will be in the direction of the lone pair. So here this is polar, and here less polar. So this polarity will explain the boiling point of these two molecules. If the molecules are polar, there will be more interaction between polar-polar interaction than the non-polar interaction. So we have to give more energy to break polar-polar interaction compared to non-polar interaction. So we have to give more energy. That means NMe3 will have higher boiling point compared to NF3. So in that case, this option is correct. The fourth option says CCl4 has less boiling point than SiCl4. The electronegativity of carbon and chlorine 2.5 and 3.1. The difference is 0.6, and that in the case of silicon and chlorine, silicon has 1.9, chlorine has 3.1. The difference equal to 1.1. So here the difference is higher value and the difference here is lower value. Lower value means more covalent. Higher value means more ionic. That means in the case of SiCl4 there is more ionic kind of interaction. That means the molecule will have strong electrostatic force of attraction that may give rise to a higher boiling point compared to the less electrostatic force of attraction between CCl4 molecules. But the observed values for these molecules, the boiling point of CCl4 is somewhat 76 degrees Celsius and boiling point of SiCl4 is 57 degrees Celsius. So we were expecting SiCl4 should have higher boiling point and CCl4 should have lower boiling point. So this question has one exceptional option, which is CCl4 has less boiling point than SiCl4. That is also wrong, because the observed value for CCl4 is 76 degrees Celsius and the observed value for SiCl4 is 57 degrees Celsius. So the correct option in this question is option C. So answer is C. I hope this answered your question. Hi, our question is, which of the following statements is incorrect? Option A, disproportionation reaction takes place for the hydrolysis of HCF4. Option B, in the hydrolysis of PCl3, tautomers of POH thrice are formed as final products. Option C, in the hydrolysis of NCl3, HOCl is not formed. Option D, CH4 is inner towards the hydrolysis at normal conditions. Let us take option A. When xenon chloride undergoes hydrolysis, it gives xenon plus an explosive compound called XeO3 along with hydrogen fluoride and chloride gas. To balance this equation, you have to multiply 2 here, 3 here, 6 here. So this balanced chemical equation shows that xenon fluoride on hydrolysis undergoes disproportionation reaction to give xenon gas, then XeO3 along with hydrogen fluoride and fluoride gas. So our option A is correct. Let us take the second option. It says, in the hydrolysis of PCl3, tautomers of POH thrice are formed as final products. So PCl3, when undergoes hydrolysis, it gives 3 moles of HCl and 1 mole of POH3. So this POH3 thrice, the structure is OH, OH, OH. It exists with another tautomer. Predominant tautomer structure is so our second option is also correct. Let us see option C. In the hydrolysis of NCl3, HOCl is not formed. Let us see what will be formed when NCl3 gets hydrolyzed. NCl3 on hydrolyze, it will give ammonia and HOCl. To balance this equation, let's put 3 here, 3 here. So 1 mole of NCl3 will give 1 mole of ammonia and 3 moles of HOCl, hypochlorous acid. So our option C says HOCl is not formed, so this option is incorrect. Option D, it says CH4 is inert towards the hydrolysis at normal conditions. So when something is getting hydrolyzed, it means that we have to break the hydrogen bonding in the water molecules first. So when a non-polar molecules like CH4 interact with polar molecules like water, we cannot expect any interaction there. What we should expect is non-polar will dissolve non-polar and polar will dissolve polar. So these two will happen, but non-polar with polar will not happen. So our option D says CH4 is inert towards the hydrolysis at normal conditions. It is correct. So our answer to the question is option C. That is the incorrect statements given in the question. I hope this answered your question. Hi, our question is, which of the following diagrams indicate the formation of pi bonds? Option A. In this case, we have two d orbitals overlapping sideways. Option B, one p orbital and one s orbital. Option C, an overlapping of one p orbital and d orbital. And option D, overlapping of two d orbitals in a special way. Let us examine each options. So option A, it is clearly showing a pi bond. So option A is correct. Coming to option B, p orbital double shape plus p orbital s orbital. They can overlap only in sideways and forms like this. So this is sigma bond. So option B is not a pi bond. Coming to the option C, it is clearly showing an overlapping, sideways overlapping of p and t orbital. That is also correct. So option A and option C shows pi bonds. While examining the fourth one, here two d orbitals are overlapping in a superimposing manner. This is not sideways overlapping but superimposing. So this kind of bond is called delta bond. So in our question, our answer is option A and C. I hope this answered your question.